Okay, 7.5 is like 7.4, except in 7.5 you have to actually set up the problem first, and then do the simplex tableau, and then you have to set it up. You have to actually set up the initial simplex tableau, and then you do your pivoting, and then you solve for your maximum. So I'm gonna work through a couple word problems for you. So again, you have to set up the objective function with constraints, and then set up the initial tableau. So we have to set all of this up on our own. That's the difference. So let me walk you through this. A farmer has 120 acres of land available. He wishes to plant with a mixture of potatoes, corn, and cabbage. It costs him $400 to produce an acre of potatoes, $160 to produce an acre of corn, and $280 to produce an acre of cabbage. He can spend up to $20,000. He makes a profit of $120 per acre of potatoes, $40 per acre of corn, and $60 per acre of cabbage. How many acres of each crop should he plant to maximize the profit, and what is the maximum profit? So we're trying to maximize the profit. So it says how many acres of each crop. So there's potatoes, corn, and cabbage. So we let x1 be the potatoes, x2 be the corn, x3 be the cabbage. Or you can change that around, but I thought I'd keep it the way I heard it. So you have your crops and you have your x1, x2, x3. Now you're given a couple of things. You're essentially you're looking for to maximize the profit. So you're looking to see essentially he makes a profit of 120 per acre. So there's a profit per acre leading to the total profit. There's a cost per acre. So those are the factors that it's giving you. Uh, that kind of tells you what you're dealing with here. Now he has essentially 120 acres of land available. Uh, so essentially, I change this to 120 here. For some reason I put 100 here. He has 120 acres available completely. So he has a maximum 120 acres available. So I'm going to put that 120. It'll be easier here to see. And this would be essentially 120. I caught that mistake before I did this. So let me just change that to 120 real quick. Okay, so it costs him $400 for an acre of potato, $160 for an acre of corn, and $280 to produce an acre of cabbage. So this is how much it costs for each acre of these things. Okay? So the restriction is the total number of acres that he has available, and the constraint is the constraint is how many acres available, and how much it's going to cost, what he has to deal with, how much money he has to play with. So he can spend up to 20,000. So the total cost is 20,000. So 400 times the number of acres of potatoes, plus 160 times the number of acres of corn, plus $280 times the amount of acres of cabbage. That should be less than the 20,000 he has to spend, because that's how much money he's spending. His cost. This is the number of acres that he's using, and it says 120 acres total. This is what he's looking for as a profit. So 120 times the number of potatoes, 140 times the number of acres of corn, and 60 times the number of acres of cabbage. That should be your z function. That's where I get this. So you have to have at least 0 potatoes, 0 corn, and 0 cabbage. You can't have negative corns, negative cabbage, and so on. So getting the slack variable, you have 2 slack variables because there's 2 inequalities here in the constraints. So S1 and S2. I changed that to 120. I had it at 100. I did it at 120 when the problem. So thank God for that. So I go down here. Again, I put in all these numbers into my tableau. Negative 120 is my most negative indicator. So these two guys, one of these is going to be my pivot. So if I divide 120 by 1, I get 120. If I divide 20,000 by 400, I get 50. So this gives the smallest value. So I'm going to divide everything here by 400, and I'm going to simplify. And I think for simplicity, I use decimals. I use decimals here because it goes to the 10th place. It doesn't go like 0.7264825, whatever. It just goes, it doesn't go that bad. Maybe 4 decimal places. It doesn't go too far. It stops. It's terminating decimal. If I divide everything by 400, then I'm going to multiply. Essentially, I did R1 minus R2, which means I multiply essentially this one by -1. And I add it. -1 plus 1. -0.4 plus 1. -0.7 plus 1. 0 plus 1. negative 0.0025 plus 1, 0 plus 0, negative 50 plus 120, 70. No more negative indicators, so I've pivoted completely. So this column, and this column are my non-basic variables. They're pivoted. So x1 is 50, s1 is 70, x2, x3, s2 are 0. My maximum is 6,000. So by planting 50 acres of corn, I get a maximum profit of 6,000. This slack variable says essentially I need to add that on to get my maximum. So it kind of picks up the slack, an extra variable into the equation or into the inequality. That's essentially how I set up the problem and I solve it. I don't know how many of these I did here. I did one more. I think it just because the solving of it is not that bad. It just set it up. So we're gonna set up the initial tableau, the simplex tableau, and we're gonna do the pivoting. So we're gonna illustrate objective function and constraint. So a baker has 60 units of flour, 132 units of sugar, 102 units of raisins. A loaf of raisin bread requires 1 unit of flour, 1 unit of sugar, 2 units of raisins, while a raisin cake needs 2 units of flour, 4 units of sugar, and 1 unit of raisins. If raisin bread sells for $3 a loaf, excuse me, and raisin cake sells for $4 a loaf, how many of each should be baked so that the gross income is maximized? And then what is the maximum gross income? So you're trying to maximize how much money he makes for doing this. So it's how much you sell. One sells for 3, one sells for 4. So if x1 is the raisin bread and x2 is the raisin cake, so the bread is x1, the cake is x2. So just kind of setting that up here. So your maximum gross is 3x1 plus 4x2. That's kind of what you're trying to maximize, a profit. So you're given 3 things: units of sugar, units of raisins, and units of flour. So let's talk about those 3 things. So in the how much flour is included here, or if you go across raisin bread, 1 flour, 1 sugar, 2 raisins. Raisin cake, 2 raisins. Excuse me, no, I'm sorry, 2 flour, 4 sugar, and 1 raisin. So the amount of flour comes from both cake and bread. The amount of sugar comes from also bread and cake, and the amount of raisins comes from bread and cake. So this is how many units of flour you have to play with, how many units of sugar you have to play with, and how many units of raisin you have to play with. So these two have to be essentially less than 60 or equal to 60. These two have to add up to less than or equal to 132 again, with x1 and x2 in there. 2x1 plus 1x2 has to be less than 102 or equal to 102. And that's what you have. So it doesn't say you have to sell so many breads. It doesn't say anything about at least 5 loaves, at least 2 loaves. It doesn't say anything at all about that. So we use them into the formulas, into the inequalities. So moving this around and put into my tableau, I get all of these values. My negative 4 actually here, the second number is my most negative indicator, this guy. So I go up here and I say they're all positive. So 60 divided by 2, 132 divided by 2, 102 divided by 1. 102 divided by 1 is 102. 132 divided by 4 is 33. 60 divided by 2 is 30. So this is your pivot. So I'm going to divide everything here by 1. Excuse me. I'm going to divide everything here by 2 to get a 1 there. And so let me put that over here. Here's a problem kind of worked out. I'm not going to spend too much time on it because it's kind of the same thing as I've been teaching before. But you're trying to make all these zeros. So again, you're multiplying by negative 4 to add to a positive 4 to get a 0. You're multiplying by negative 1 to add to a 1 to get the 0. And you're multiplying by a positive 4 to the 1 to add to 4 to get 0. You go through all of that work, because again, I don't have room for all that here. I get all of these values. You can verify that on your own. Sadly, there is another negative indicator here. So going up the line, these two essentially are the only ones that you're looking for the pivot row because they're positive. So if I multiply this by 2/3 or divide by 3/2, essentially, I get what? 48 30 divided by a half is 30 times 2 over 1, which is 60. So this is my pivot. So I have to multiply everything by 2/3, which I get fractions. Then because these are negatives, I just add them. Because of 1/2, I have to multiply this by a -2 to make it a -1, to add to a +1. So I go through all the pivoting, and I get this simplex tableau. Now, I talked about ones and zeros. It's also, it doesn't have to always be a one and it doesn't have to always be a one and all the zeros. Now, technically, this is not pivoted, but because they're all zeros and one of them is not zero, this will play the role of pivoted, even though it's not, because I can easily take all of this and divide by -2. That's not a problem. So any column that has all zeros, except one number that's not zero, that's the answer for that. So then you set it equal to the end. So -2x2 has to equal -12. So x2 is 6. The z value is 168, my maximum, and my x1 value is 48, which means s1, s2, s3 are zeros. Those are my non-basic variables. So my two variables, x1 and x2, the amount of essentially what? Raisin bread and the amount of cake. So I make 48 loaves of raisin bread, and I make 6 loaves of cake and 6 raisin cakes. I get a maximum gross income of 160. So it says how many of each is going to maximize it? Well, 48 raisin breads, 48 loaves of raisin bread, 6 raisin cakes. That's going to give a maximum gross of $168. And essentially, this includes 7.5 for us. Now, 7.6 also is there. It's called the duality method. Now, the duality method, instead of asking for a maximum, it talks about a minimum. So a lot of it, we're not going to do it, so don't panic. But a lot of it, instead of less than, is either all greater than or a mixture of less than or greater than. So they take this matrix and they do what's called a transpose. These rows become the columns. These columns become the rows, and the matrix kind of changes a little bit, kind of goes the other way. And then you pivot with that stuff. And then you turn it back, and you do, at the end, you do the transpose back, and you get back the original problem. So it's kind of like you take the inverse and then take the inverse of the inverse back, but we're not going to do that. So this is the end of chapter 7. This is what your third test is going to cover.